Welcome guys, this is Yusuf's Science and Math class. Today we're going to continue on kinematics in one dimension. This time we're going to learn about kinematics equations and kinematic graphs. If you didn't watch a previous video about kinematic quantities and identity variables, you should probably want to watch that. So let's talk about kinematic equations. There are total 5 equations, and let's take one by one. Equation 1. D is v times t, meaning the displacement is velocity times times. Equation 2, and there is missing variable a. Equation 2 have velocity or final velocity equals initial velocity plus acceleration times times. And we don't have the d or distance or displacements there. Equation 3 means distance or final distance equals initial distance plus initial velocity times t plus 1/2 acceleration times t squared or time squared. And we're missing final velocity in equation 3. Equation 4, final distance equals initial distance plus velocity times minus 1/2 accelerations times time squared. And we are missing initial velocity there. And last, final velocity squared equals initial velocity squared plus 2 accelerations times distance. And we are missing t. So, for example, the question does not give distance and only gives velocity and acceleration. We can use equation 2 to calculate t because we don't need distance, but we have velocity, which is initial velocity and final velocity and acceleration. So let's go to problems. Determine the maximum speed of the ball that is dropped from 90 meters. You should know some of the hidden variables here. You should probably need some time, so if you need time, please stop this video until your work is done, and I'll give just answer right now. So first, find the non-constant and hidden values. So let's say hi, I'll say h, or you can say x because it is the dropping, so I want it as a height. Hi is 90 meters, and hf is 0 meters. T is not mentioned in here, and g, or a, is negative 10 meter per second squared, and vi, because it is dropped, vi initial velocity is 0, and we are trying to find the final velocity. So we need to find final velocity, but we don't have t. We can use equation 5, which is final velocity squared equals initial velocity squared plus 2g delta h. And we can get root 900, which is 30 meters per second. Let's go to kinematic graphs. So if you see position x versus time, we have to write velocity as a slope, and y-intercept as initial position, and x-intercept as when x equals 0. When kinetic graph is velocity versus time, the slope is acceleration, the area is a displacement or change in position or delta x, y-intercept is initial velocity, and x-intercept is when v equals 0. If you see acceleration versus time, slope, we don't need to know about right now in this physics. Area is change in velocity, y-intercept is initial acceleration, x-intercept is when acceleration equals 0. Let's go to kinematic graphs problem. A. Determine the initial position of the object. I'll give you a few seconds. A. Initial conditions occur at 0 time because the initial position. In graphs with time along the x versus initial values are the y-intercepts. Therefore, the initial position is at 15 meters. How about B? Describe the motion during the first second. Please stop video if you need time. And let's say, negative slope line indicate that position is going negative, meaning decreasing. At 1 second, position is 0 meters. How about C? Describe the motion during 4 to 6 seconds. Again, please stop this video. The horizontal line indicates the independent variable position remain constant. The motion during the first second constant position not moving. Let's go to determine the velocity during the 2 to 4 seconds. During the interval 2 to 4 seconds, the position have moved from 0 to 10 meters. Therefore, the velocity is 10 meters per 2 seconds, which is 5 meters per second. Okay, did you understand all of it? I hope so. And if you like this video, please subscribe and like. And if you have any questions, please write in comments. And I'll see you next time. Bye.